the age of 7, I took up magic after my swim team coach started giving beginners lessons at the local rec center. Magic is what pushed me towards psychology. Supportive professors during my undergraduate and graduate studies encouraged me to think more deeply about how the techniques that magicians were using mapped on to psychological concepts I was learning in class. Magic pushes lots of people towards psychology because magic is essentially applied cognitive science. Everything a magician does is driven by their theory of mind, by their assumptions about how attention and perception work, and about how they can be deceived. Learning magic increases your awareness of how prone we are to detecting illusory correlations. Is this pen a magic wand that caused the coin to vanish? Or is it just a hook that reeled you into accepting an erroneous causal inference? It's my hope that today, your knowledge of psychology will bring an interest in magic. Magic can be a powerful tool for psychological science, for identifying hypotheses to be tested, and also just as a toolbox of techniques that can be implemented into the laboratory. This is a Morgan silver dollar, minted in the 1890s, a time period when psychologists first became interested in the techniques of magicians. In this one decade of the 1800s, at least 4 manuscripts were published on the psychology of magic. And these were published by real movers and shakers in the field, names you know. People like Alfred Binet, who's also credited with capturing the first moving pictures of a performing magician. Joseph Jastrow, who founded the famous psychology department at the University of Wisconsin. And Norman Triplett, whose doctoral dissertation under the guidance of G. Stanley Hall was on the psychology of magic, and who's later credited with carrying out the first experiment in social psychology. So what was going on in that decade of the 1800s that brought about this sudden interest in the methods of magicians? Well, America was a kooky place in the mid-1800s. It's still a kooky place. But in the mid-1800s, new religious belief systems like spiritualism and mesmerism were popping up. Belief systems that brought with them extraordinary claims about psychology. For example, Franz Anton Mesmer hypothesized that we have mysterious energies like chi or pneuma flowing through our bodies, and that an imbalance in these energies is the source of all illness. Through what he called animal magnetism, my energies could influence your energies, and illnesses could be alleviated through the laying on of hands. While people were under Mesmer's influence, while they were mesmerized, they claimed to have all sorts of experiences. They claimed to have spoken with the dead, or to have their consciousness travel to different times or different places. Mesmerism paved the way for hypnosis as we know it. And even though it was well before the birth of Carl Sagan, psychologists of the era knew that extraordinary claims required extraordinary evidence. So in service of evaluating the claims made by spiritualists and mesmerists, the Society for Psychical Research was founded in 1884. Among its charter members were names you've already heard today: Joseph Jastrow and G. Stanley Hall. Fewer than 10 years later, both of these men and many others jumped ship from the organization. It had become something other than what they'd envisioned for it. Rather than evaluating reality, many of the members seemed more interested in finding evidence to support their deeply held beliefs about the world. This was not the kind of science that these men had envisioned. This small group of scientists who disbanded from the organization turned their attention to magicians. Spiritualists who made their living claiming to talk to your dead relatives were unlikely to be forthright with the scientists if they were using deceptive techniques to produce their phenomenon. Magicians, on the other hand, were upfront about the fact that they were liars and deceivers, and perhaps they might be a little bit more honest about the techniques that they're using. And those techniques might lend some insights into the psychology of perception and the chinks in the cognitive armor. The emergence of behaviorism in the next century seemingly put a stop to this interest in the methods of magicians. But fast forward a century, and once again, psychological scientists are looking to magicians for the insights they can bring to the scientific study of the mind. In my laboratory at Carthage College, I've taken two approaches to the scientific study of magic. In some instances, I borrow techniques and introduce them into the laboratory to increase the ecological validity of my methods. But in the other approach, my students and I mine the writings of magicians for hypotheses about psychology that are as yet untested. For example, in recent years, I've been exploring how magicians control an audience's attention. Not just where they're attending, but when they're attending. It turns out both scientists and magicians use the same metaphor for attention, that of a mental spotlight that's moved around the environment. Of course, overuse of this analogy has limited our thinking, encouraging us to neglect how attention may actually wax and wane in time. Magicians have rich intuitions about how they can control attention in time, creating what they call offbeats, moments of visual attentional suppression. And they create these offbeats through a variety of different mechanisms. The most interesting for today being through the creation of a visual or auditory rhythm. While scientists have known for many years that rhythm within a sensory system can lead to entrainment or a synchronization of attention with that rhythm, what magicians seem to be doing is using oftentimes an auditory rhythm to influence visual awareness. Inspired by this, recent research from my lab has provided some of the very first evidence that the mere presence of an auditory rhythm can influence visual detection. Participants in my experiment engaged in a difficult visual detection task. Meanwhile, they heard tones, rhythmic tones, played over some headphones. The appearance of the visual stimulus could happen on the beat or could be shifted in between beats. We found that people were less likely to detect this visual event if it happened off the beat, out of synchrony with this rhythm, even if the rhythm was irrelevant to the task at hand. To return to magic, if I create a rhythm, sleight of hand that happens off the beat is more likely to evade detection, leading to powerful illusions like this. Even if you know what's happening, this kind of rhythmic entrainment makes it near impossible to see the sleight of hand. It seems that perhaps a more apt analogy for attention is that of a blinking spotlight that sporadically samples information from the sensory stream. So while this experiment on attention only took its inspiration from magic, other research from my lab borrows techniques directly from magic, although not always to magical ends. Here's a stimulus from a series of experiments carried out in my lab. I'd like you to watch this video. After you've watched it, I'll ask you some questions about what you've seen. At this point, participants were asked where the coin was when last they saw it. Was it under cup A on the left or under cup B on the right? What do you think? The correct answer, cup A. If you got it wrong, here's a chance to redeem yourself. Watch the video again. So if you failed to see the coin move, you fell prey to a phenomenon called inattentional blindness, our tendency to miss an unexpected event when we're engaged in an attentionally demanding task. Many inattentional blindness tasks have an explicit task that participants have to engage in that draws attention away from the unexpected. You've probably seen the famous invisible gorilla demonstration by Dan Simons and Chris Chabris. In that task, participants had to count how many times basketball players wearing white shirts passed basketballs while ignoring basketball players in black shirts. This is an explicit orienting task. In the case of my experiment, the task was implicit, as the viewer attempted to build a narrative to understand what they were witnessing. In one experiment, we tracked participants' eye movements as they watched this video. We wanted to see whether there were any relationships between eye movements and inattentional blindness. While just over half of participants were blind to the moving coin, we couldn't tell who had and who hadn't seen the coin based on where they were looking at the midpoint of the coin's movement. Those who saw the coin and those who didn't were looking at the exact same spot on the computer screen. Obviously, though, they weren't attending to the same spot on the computer screen. In a series of follow-up experiments with my colleagues at Harvard, SUNY Downstate Medical Center, and Arizona State University, we observed that microsaccades, tiny movements of the eye that are made while you're fixating, actually predict whether a person will succeed or fail at a task like this. It seems that these tiny, almost invisible eye movements point to where attention is placed independently of where the eyes are pointed. So, if you're trying to watch my hand while also attending to the mug to see when I sneak the coin under there, you're probably fixating here, but your eyes are making a lot of vertical microsaccades as you divide your attention between these two locations. Of course, those microsaccades won't matter much if I snuck the coin under there during a moment of inattention. Some might take this as evidence that the eye is quicker than the hand. So obviously, I believe that there's great value to be had in collaborations between the arts and sciences. Exploration of folk psychology from the arts can speed our rate of scientific discovery. It can encourage us to be more creative. It can lead to the adoption of more powerful, ecologically valid techniques for our laboratory research. However, these collaborations aren't without their challenges, the foremost of which being that magicians and scientists use a different language. Magicians typically don't need to operationalize their ideas the same way that scientists demand. So it takes a little bit more work up front to really pin down what these ideas mean from the arts. I've got a small leg up on that thanks to my background in magic, but you don't need to have a background in magic to do this work. Here's a dirty little secret. Every city in America has magicians who make their living performing for the masses. They're all around you. It's terrifying. And many of these magicians have a deep knowledge of the foundational texts in magic, the same texts that drove the techniques I'm describing today. Many of these magicians also happen to be rabid supporters of science. I believe that learning magic can be a boon for skepticism and critical thinking, but that's a topic for another day. I suspect that your friendly neighborhood magician would be open to being approached by a scientist like you, and that they may even be open to entering into a collaboration. If that's beyond your comfort zone, I get it. In 2017, my colleagues and I founded an organization, the Science of Magic Association, whose mission is to promote rigorous research directed toward understanding the function, nature, and underlying mechanisms of magic. Since the group's founding, we've had 2 conferences, one in London, one in Chicago. Our next conference is planned for the summer of 2021 in London. Our keynote speakers at these events have been icons in both psychology and magic. We've had Dan Simons and Elizabeth Loftus from psychology, Juan Tamariz, Simon Aronson, and Mac King from magic. And these conferences provide an informal opportunity for scientists and magicians to get together, build relationships, establish collaborations, and shared interests. I encourage you to seek out more information about the organization at scienceofmagicassociation.org. Today's presentation would not have been possible without my many collaborators, colleagues, and the many students who contributed to this research program. While good science happens through collaboration, the best science happens through interdisciplinary collaboration. I'm continually appreciative that the Magic community is filled with folks who have deep respect for science. I hope you've enjoyed my presentation today. I also hope you'll go forth with a little bit of magic on your brain. Thank you.